What is algebra, and why do so many people have trouble understanding it? One of the problems is that in order to understand algebra, you have to first know what it is. Well, basic algebra is nothing more than plain arithmetic. Now that may surprise you, but that's all algebra is, just arithmetic and nothing more. If you know how to add, subtract, multiply, and divide, you can solve basic algebra problems. Let's see if we can't take the mystery out of algebra so we can easily solve basic equations. Because I just said that basic algebra is nothing more than plain arithmetic, we have to first look at how beginning math problems are structured so that we can then apply these concepts to understanding basic algebra. Then we'll end this video by solving these problems on the wall. I'll be using examples so that the answers will come out positive in order to avoid arithmetic with negative numbers. So let's get started. Let's take this simple word problem. Let's suppose I have $3 in my pocket and $5 on my desk. How much money do I have altogether? As you can see, this is a simple, straightforward, basic arithmetic problem. This is the kind of one-step problem that people first learn to solve when learning basic math. I'm given two pieces of a problem, then asked to somehow combine those pieces together in one step to get an answer. In order to solve this problem, I have to mentally add two numbers together to find that answer. $3 plus $5 is $8. Whether you realize it or not, this happens to be an algebra problem. This is what algebra is all about, solving arithmetic problems. Sometimes the problems are simple, and other times the problems are complicated. If you properly learn the rules of algebra, you can then solve many types of algebra problems. You start by learning simple one-step, straightforward problems, then you progress to multiple step problems, the kinds of problems where you have more than one arithmetic operation in them. You can write this simple arithmetic problem two different ways. When you first learn basic arithmetic, you write the problem straight up and down like this. $3 plus $5 equals how much? You can also write this problem horizontally this way. It's a good idea to start writing problems this way because they are easier to solve when they get more complicated. Now let me change the problem a little bit. Suppose I have some money in my pocket and I also have $5 on my desk. Altogether I have a total of $8. How much money do I have in my pocket? This is almost the same as the first problem. I'm still adding two numbers together to get the answer, only in this problem one of the pieces is missing and I'm giving the other piece in the answer. In order to solve this problem, I have to work backwards and subtract the piece that's given from the answer to get back the other missing piece. $8 minus $5 is $3, the amount I have in my pocket. You can also write this problem horizontally like this. In this form, I still do the same thing to solve it. Subtract this $5 from the answer part to get back the other piece, which is $3. That was an example that involved an addition problem. Let's look at a different one. I went to the store with $12 and spent $5 while there. How much money do I have left? This is a straightforward subtraction problem. We're given two pieces of a problem, then asked to do a simple arithmetic operation to get an answer. And you can also write the simple subtraction problem horizontally like this. These are the two pieces, the arithmetic operation of subtraction, and the answer. In order to find the answer, I have to mentally perform subtraction. $12 minus $5 to get the answer, $7. That was an easy, straightforward subtraction problem. Let me change the problem a little bit. I went to the store with some money in my pocket. After shopping and spending $5, I found that I had $7 left. How much did I have in my pocket before I went shopping? Again, this is similar to the previous problem, except now it's not a straightforward subtraction problem. It's still a subtraction problem, but only now I'm given one piece of the problem and the answer, and the other piece is missing. And as in the other problems, this can also be written horizontally like this. This is more typical of an algebra problem, and remember, that's what I said algebra is, just solving arithmetic problems. Now in order to solve this, I have to perform some mental arithmetic. Only I have to work backwards to find the missing piece. Here I have to add the pieces that's given to the answer to find the other missing piece. $5 plus $7 is $12, the original amount I had in my pocket before I went shopping. Looking at the horizontal version, again I have to add the $5 to the $7 to find the missing piece, which is $12. So the missing piece is equal to $12. Here's another problem. Suppose I have $5 and my friend has 3 times more than I do. How much money does my friend have? As you can see, this is a straightforward, simple one-step multiplication problem. I can also write it horizontally like this. To solve it, I have to mentally multiply $5 times 3 to get the answer $15. Another thing you should know is that there's several different ways to write multiplication problems. Like this with the large X indicating multiplication, with parentheses around both numbers indicating multiplication, or a parentheses around one or the other number, or with a dot between them. All of these mean you're multiplying two numbers together. For right now, I'll use this form, but be aware that it's better to use one of these 3 forms when writing algebra equations. When written in this form, we again just perform straightforward mental multiplication to find the answer. $5 times 3 to get the answer $15. Okay, what if I had this situation? I have some money in my pocket, and my friend has 3 times more than I do. The amount my friend has is $15. How much do I have in my pocket? When I write this out using math symbols, you can see that I'm given one of the pieces and the answer, and the other piece is missing. By now you should know that means I'll have to work backwards to solve for the missing piece, or the amount I have in my pocket, because this is no longer a straightforward multiplication problem. In order to find the missing piece, I have to work backwards by dividing the answer by the piece that's given, which is 3 to get 5, or $5, the amount I have in my pocket. This problem can also be written horizontally like this. In the horizontal version, I still must divide the answer by the given piece and get 15 divided by 3, which is 5, or $5. So far, we've looked at a simple addition problem, a simple subtraction problem, and a simple multiplication problem. Now let's look at one final arithmetic problem, division. Here's the problem. I have $28 and I want to divide it equally between 4 people. How much would each person get? This is a straightforward, simple one-step division problem. Here's how you would write this using math symbols. This division problem can also be written 2 other ways, like this. In order to figure out how much each person would get, I have to mentally perform a simple division operation. 28 divided by 4 is 7, or $7, the amount each person would get. In the second form, it's still 28 divided by 4, which is still $7, and in the last form, it's 28 divided by 4, which is $7. This is the form more commonly used in algebra problems because it's easy to work with in equations. Suppose I have this problem. I have some money and I want to divide it up equally between 4 people. After dividing it up, each person gets $7. How much did I originally have to start with? We still have a basic one-step problem, only now I have to find the missing piece instead of the answer. That means I have to work backwards to find it. Here are the 3 different ways to write this problem, using the division house, horizontally like this, and in fraction form like this. Since I'm given one piece of the problem and the answer, I have to work backwards to find the other missing piece, the amount I'm dividing up. I have to multiply these 2 numbers together to get back the missing piece, which is 4 times 7 to get 28, the amount I divided up. The same as in the second form, I have to multiply 7 times 4 to get 28. And in this form, I have to multiply these 2 numbers, 4 times 7, to get 28. It's very important to understand what we just did in order to comprehend the concept of algebra. Normally, this is the type of problem students first learn to solve. You're given some pieces of a problem, then asked to somehow combine those pieces with an arithmetic operation to get an answer. Pretty simple and straightforward. These also happen to be simple algebra problems, because you're solving a problem where something is missing. These problems were just like the previous set of problems, only these are more typical of algebra problems. With algebra problems, you usually have to work backwards to find a missing piece. I mentioned in the beginning of this video that algebra was nothing more than arithmetic. As you saw, these 4 problems are nothing more than simple one-step arithmetic problems that involve a simple arithmetic operation. Let me write these problems horizontally like this. I first posed these as real-life arithmetic money problems, but let's look at these as just pure algebra problems with plain numbers instead of money. Let me read the first one. I want to find a number so that when I add 5 to it, it's the same as 8. The second one reads, I want to find a number so that when I subtract 5 from it, it's the same as 7. The third one reads, I want to find a number so that when I multiply it by 3, it's the same as 15. The fourth one reads, I want to find a number so that when I divide it by 4, it's the same as 7. The first thing you need to do when given an equation is to read it to know what's there. Then you learn how to systematically take it apart to solve for the missing piece. In order to solve an equation, you must know the rules of algebra. Those rules are very simple. As I said in the beginning, algebra is nothing more than arithmetic, and that's what you must learn, how to apply the arithmetic to solve an equation. I also said that if you know how to add, subtract, multiply, and divide, you can solve equations. Now let's look at the first problem again. The object in solving any equation is to get the missing piece or the unknown on one side of the equal sign and a number on the other side. You do this by systematically taking the equation apart using arithmetic until you have the missing piece by itself on one side and a number on the other side. Think of the equal sign as a barrier dividing the left side from the right side. And you can also think of the equal sign as a balancing point or a teeter-totter. What that means is that whatever you do to one side of the equation, you must do the same thing to the other side to keep it balanced or equal. That is the first basic rule for equations. You can do whatever you want to an equation, provided you do the same thing to both sides to keep it equal. Okay, let's solve this as an equation. I want to first identify which side the unknown is located. It's located on the left side. Next, I can see that it's not by itself on the left side, and I want to undo whatever it is that's being done to it to get it alone. I can see that 5 is being added to it, so in order to get rid of the 5, I have to do the inverse or opposite of addition, which is subtraction. I have to subtract the 5 to get rid of it on the left side. Now, if I subtract 5 from the left side, I have to do the same thing to the right side to keep the equation balanced. 5 minus 5 is 0, which just leaves a missing piece on the left side. Now I also have to do the arithmetic on the right side. 8 minus 5 is 3. So you can see that the missing piece is 3. That means that if I replace the question mark in the original equation and do the arithmetic, I can see that 3 will make the left side the same as the right side. Now let's look at the second one. I'm going to read it first. I want to find a number so that when I subtract 5 from it, I get 7. Again, the object here is to get the missing piece on one side by itself and a number on the other side. So let's take it apart. I can see that the unknown is not alone on the left side. 5 is being subtracted from it. So I have to do the inverse of subtraction, which is addition, to get rid of the 5. I have to add 5 to the left side to get rid of it, so I also have to add 5 to the right side to keep the equation balanced. The 5's on the left side cancel each other out, leaving the missing piece. And the arithmetic on the right side is 7 plus 5 to get 12. Now I can clearly see what the missing piece is supposed to be. It's supposed to be 12. 12 is a number that will make the left side the same as the right side. Now let's look at the third one. Again, I'm going to read it to make sure I know what's there and to make sure I understand it. I want to find a number so that when I multiply it by 3, I get 15. As in the previous problems, the object is to get the unknown or missing piece alone on the left side and a number on the right side. It should be pretty clear that the missing piece is not alone on the left side. It's being multiplied by 3. In order to get rid of that 3, I have to undo multiplication by doing the inverse or by dividing. That means I have to divide the left side by 3 to get rid of the 3. If I divide the left side by 3, I also have to do the same thing to the right side. Divide that side by 3 also. On the left side, the 3's cancel each other out, leaving the missing piece by itself, which is what I wanted. I also have to do the arithmetic on the right side, divide 15 by 3 to get 5. The missing piece I was looking for is 5. If I replace the question mark with 5, you can see that that makes the left side the same as the right side. Now for the last one. I read it as I want to find a number so that when I divide it by 4, it's the same as 7. Just like the other problems, I want to get the unknown piece on one side and a number on the other side. The unknown piece is not by itself on the left side, it's being divided by 4. In order to undo being divided by 4, I have to multiply by 4. So that means I have to multiply the left side by 4 to get rid of it. Now if I multiply the left side of the equation by 4, I must also multiply the right side by 4 to keep the equation balanced and equal. Now doing the math on the left side first, because this is the fraction, I can write the multiplier as the fraction 4 over 1 and just do fraction multiplication. Here the 4's cancel out, leaving the missing piece over 1, and anything written over 1 is just that thing by itself. On the right side, since 7 is a whole number, I just multiply it by 4 to get 28. So the missing piece I was looking for is 28. If I plug 28 back into the original equation and do the arithmetic, 28 divided by 4, you can see that the left side is equal to the right side. These 4 problems were simple one-step algebra problems. One of the things that makes solving algebra equations so easy is that everything you have to do to solve them will be right in front of you. You simply read the equation, look at where and what's being done to the unknown piece, and simply undo that arithmetic to solve it. In the first one, the only arithmetic operation here is addition. 5 is being added to the unknown, so to undo the 5, you have to subtract 5 from both sides. In the second one, the only arithmetic operation here is subtraction. 5 is being subtracted from the unknown, so to undo that, you simply add 5 to both sides. In the third one, the only arithmetic operation here is multiplication. It's being multiplied by 3, so you divide both sides by 3 to get rid of it. In the last one, the only arithmetic operation here is division. The unknown is being divided by 4, so you have to multiply it by 4 to get rid of it. Here's the first basic rule for solving equations. You need to know the inverse of the 4 basic arithmetic operations in order to undo or take apart an equation to solve it. Here are the 4 most basic arithmetic operations: addition, subtraction, multiplication, and division. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is to divide, and the inverse of division is to multiply. You can solve most basic equations performing one or more of these basic operations. Let's see if we can now solve problems with more than a single arithmetic operation in them. What if I have $9 and I want to multiply that by 2, then add $3 more to it? How much would I have altogether? Let's put that in math symbol form. I have $9 and I want to multiply that by 2, then add $3 more to it. How much would I have altogether? Here's how it would look written horizontally. This is just an arithmetic problem, only now you have to perform 2 steps to solve it. It involves multiplication first, then addition second. When you begin to have more than one arithmetic operation in a problem, it's a good idea to start writing them horizontally instead of vertically like this. I can still easily solve this because it's straightforward arithmetic. I have to mentally multiply 2 times $9 to get $18, then mentally add $3 to that to get the answer, $21. In the second version, I still solve it the same way by first multiplying 2 times $9 to get $18, then add the $18 to the $3 to get the answer, $21. So the missing piece I was looking for was the answer, which is $21. This next problem is where it gets real interesting. It's a slightly different version of the previous problem. I have some money and I want to multiply it by 2, then add $3 more to it so that it equals $21 altogether. How much did I have to start with? Here's the problem written with math symbols. I have some money and I want to multiply it by 2, then add $3 more to it so that it equals $21 altogether. How much did I have to start with? You can write this straight up and down like this since it's just an arithmetic problem, but it's going to be hard to solve it this way. It's better to write it horizontally like this. Let's take a closer look at what we're trying to do here in this equation. I need to figure out how much money I have to have so that when I multiply it by 2, then add $3 more to it, it has to be the same as $21. Remember, the object in solving an equation is to get the missing piece by itself on one side and the number on the other side. If you look at this, the missing piece is on the left side, but it's not by itself. First, it's being multiplied by 2, then 3 is being added to it. There are 2 arithmetic operations on the unknown here. Multiplication first, then addition second. It's being multiplied by 2, then 3 is being added to it. Like I said before, algebra problems are extremely easy to solve because everything you have to do will be listed right in plain sight in front of you. Remember to treat the equal sign as a barrier, and we're going to focus on the left side to try to get that missing piece by itself. You simply look at what's happening to the unknown and just undo it or take it apart step by step. We're going to undo these things only in reverse order. We're going to undo the second thing first and the first thing second. So we undo this first. 3 is being added to the unknown. So to undo that, I have to subtract 3, but I have to remember to do it to both sides. On the left side, plus 3 and minus 3 cancel each other out to leave 2 times the unknown on the left side. I have to do the arithmetic on the right side, which is subtract 3 from 21 to get $18 on that side. Now the next thing I have to do is undo the 2 that's multiplying the unknown by division. I have to divide both sides by 2 to get rid of the 2 on the left side. The 2's cancel each other out. And on the right side, 18 divided by 2 is $9. So the piece I was looking for that would make this side equal to this side is $9. $9 was the amount I had to start with. In order to check it to make sure, I just put the 9 where the question mark is and simplify the left side to make sure it's the same as the right side. 2 times $9 is $18. $18 plus $3 is $21. This would be a typical beginning algebra problem. And in order to solve it, I just did arithmetic. I had to subtract first, then divide next to get the missing piece by itself. How about another problem? Suppose I want to find a number so that when I divide it by 6, then subtract 4 from it, it will be equal to 1. What would that number be? Remember, this is just an arithmetic problem, and it looks like I'm going to have to work backwards to solve it because one of the pieces is missing. If I read it again, it should tell me exactly what I have to do to solve it. I want to find a number so that when I divide it by 6, then subtract 4 from it, it will be equal to 1. So the first thing being done to the unknown is it's being divided by 6, then 4 is being subtracted from it. So in order to undo these two operations backwards, I have to first add 4 to both sides, then multiply both sides by 6 to get the missing piece by itself on the left side. When I add 4 to both sides, a plus 4 and minus 4 on the left side cancel each other out, leaving just the unknown divided by 6. On the right side, I have to add 1 plus 4 to get 5. The next and final step is to undo the division by 6 by multiplying both sides by 6. The 6's on the left side cancel each other out, leaving just the unknown piece. And on the right side, I have to multiply 5 times 6 to get 30. So the missing piece I was looking for is 30. Now I want to check it to make sure I found the right number. I plug in the missing number I found back into the original equation and do the arithmetic on the left side to make sure it's the same as the right side. 30 divided by 6 is 5, and 5 minus 4 is 1. You should understand by now that an algebra problem is just a bunch of arithmetic done in a certain order. There are rules about what you have to do first, second, third, and so on. As a matter of fact, algebra just means a set of rules. So we're not talking about algebra, we're talking about the algebra of equations or the rules of equations. I want to talk about a very important concept in mathematics. Understanding it will help in understanding the mechanics of equations, so I want to take a few moments to explain it. That concept is simplification. People in mathematics always want to simplify things or put them in a simpler form. People simplify things all the time. For example, let's say you had 5 apples at home on your counter and 3 apples at home on the table. If I asked you how many apples you had at home, you probably wouldn't say I had 5 apples and 3 apples. Although some people might, you would probably say you had 8 apples at home. What if you had 6 bananas on your counter and 4 bananas on the table? If someone asked you how many bananas you had at home, you probably wouldn't say you had 6 bananas and 4 bananas. You would simplify that to say you had 10 bananas at home. Now what if I had 5 apples and 6 bananas at home? Could I simplify those? No, I can't combine those together because they are two different things. I can add apples to apples and bananas to bananas. Let me shorten the apple things and just call them A things. And the banana things I'll just call B things. The idea here is that you can add or subtract like things from each other. A things to A things, B things to B things, and so on. Suppose I have 12 A things and I give away 7 of those A things. How many would I have left? Because they are both A things, I can subtract the 7 A things from the 12 A things to leave 5 A things. Now what if I have 25 X things and I want to give away 11 of those X things? How many would I have left? Because they're both X things, that means I can simplify them and subtract 11 X things from 25 X things to leave 14 X things. Now what if I wanted to add 7 X things to 9 Y things? What would that look like? Well, because they are different things, the best I can do is to write them like this. What would 14D minus 10Z look like? Well, because they are different things, the best I can do is to write them like this. In all the equations I've shown so far, I used a question mark for the unknown or missing piece. I could have just as easily used a letter for the missing piece. It doesn't matter what I use. I could have used an X, a Y, an A, an R, a Z, or a D, or any other letter I want. The only thing the letter is used for is to show that there's a missing piece, and it shows where the missing piece is located. It's nothing mysterious. It's no different than a question mark. It means exactly the same thing. This is the reason you need to know how to combine like terms. Look at this problem. I want to multiply a number by 2, then add 3 times the same number to it so that it's equal to 35. What is the number? Writing this out using math symbols, I want to multiply a number by 2, then add 3 times the same number to it so that it's equal to 35. I used a question mark for the missing piece, but you can use any letter you like instead. How about I use X instead of the question mark? And I don't need to use a parenthesis so I can drop them. Okay, so what am I trying to do here? I'm trying to find a number so that when I multiply it by 2, then multiply the same number by 3, then add those two numbers together, it has to be the same as 35. So let's now see if we can take it apart to solve it and find out what that number has to be. You'll notice that we have two x things here, so I can simplify them by adding them together first. 2x's plus 3x's is 5x's. Next, you can see that the unknown is not by itself yet. It's being multiplied by 5, so I have to undo that by dividing both sides by 5 to get rid of it. The 5's cancel out on the left side, and on the right side, 35 divided by 5 is 7. So the missing piece I was looking for is 7. Now let me check it to make sure it's the right number. I plug the 7 back into the original equation and do the arithmetic on the left side. 2 times 7 is 14. 3 times 7 is 21. 14 plus 21 is 35, which is the same as 35 on the right side. Let's see if we can solve this problem. First I'm going to read it, then I'll proceed to solve it. I want to find a number so that when I multiply it by 8, then subtract 2 times the same number so that it's equal to 30 minus 12. Here it is written in math symbols. I want to find a number so that when I multiply it by 8, then subtract 2 times the same number so that it's equal to 30 minus 12. So how do we find that number? First, let's put up our equal sign barrier to separate the left side of the equation from the right side. The first thing I can do is simplify both sides. On the left side I have two c things I can combine or simplify, and on the right side I have two regular numbers I can also combine or simplify. 8c's minus 2c's is 6c's. 30 minus 12 is 18. Next, in order to get the c by itself, I have to divide both sides by 6. The 6's cancel out on the left side, and on the right side, 18 divided by 6 is 3. Now I want to make sure I got the right number, so I'm going to plug it back into the original equation and check it. Plugging in the 3 in place of the c's, I can now do the arithmetic on both sides. Let's work on the left side first. 3 times 8 is 24, and 2 times 3 is 6 on the left side. 24 minus 6 is 18. And on the right side, 30 minus 12 is also 18. So the number that will make both sides equal to each other is 3. Now let's look at an equation where we have letter things on both sides of the equal sign and numbers on both sides of the equal sign. If you look at this equation, you can see that there's a letter thing on the left side and another one on the right side. There's also a number on the left side and one on the right side of the equal sign. Remember I said to treat the equal sign as a barrier separating the left side of the equation from the right side of the equation. Now let's look at each side of the equation. There are different ways you can interpret this equation. Looking at the left side, you can think of this as 9y minus 30, or you can look at these as two separate things, a 9y thing and a minus 30 thing. If you don't see a sign on a term, that means it's automatically positive. So the 9y is really a plus 9y. You can also think of these two things as loosely connected. You're free to move them around on the left side wherever you please. Just make sure you keep the sign with the number and don't cross the equal sign barrier. Otherwise, you have to make some changes. On the right side, I have a plus 2y thing and a plus 5 thing. And I can move the things around on the right side as I please, as long as I carry the signs along with them. I just have to be careful not to cross the equal sign barrier. If I do cross that barrier, I have to apply a special rule in order to cross it. Let's say I wanted to move everything over to the right side of the equation. I can move the minus 30 over to the right, but I have to change the sign of the number whenever I cross the equal sign barrier. So if I move it to the other side, I have to make it a plus 30. And the same goes for the 9y. If I want to move it to the other side across the equal sign barrier, I have to change it from a plus to a minus 9y. What if I wanted to move everything over to the left side? I can do that if I want to, provided I flip the signs of the terms when I cross that barrier. Okay, let's put everything back the way it was and let's see if we can solve this equation. We need to collect all the letter things on one side and all the number things on the other side first. We could collect all the letter things on the right side and the numbers on the left side, but that would make everything negative. And I haven't talked about the arithmetic of positive and negative numbers. So I'm going to move all the letter things to the left side and all the number things to the right side, and that will keep everything positive. It also makes it easier to read an equation that way. We tend to read left to right, so it makes it easier to understand an equation if we have the letters on the left side and the numbers on the right side. On the right side, I have to move the 2y over to the left side. Remember, it's not just a 2y, it's a positive 2y. When it crosses the barrier, the sign flips to negative. That's the rule. When you move a term from one side of an equation to the other side, the sign changes. Next, I have to move the 30 to the right side. And remember, it's not just 30, it's negative 30. So when it crosses the equal sign barrier, it changes to a positive. So now it's a positive 30. Next, on the left side, I can simplify or combine the y terms. 9y's minus 2y's or 7y's. On the right side, I can simplify the numbers together. 5 plus 30 is 35. Now I have one more step to do before I can get the y by itself. It's still being multiplied by 7, so I have to divide by 7 to get rid of it. I divide both sides by 7, and the 7's cancel out on the left side, and 35 divided by 7 is 5 on the right side. So the number I was looking for is 5. Now I want to make sure I found the correct number, so I'm going to check it in the original equation. I'm going to plug in the 5 in place of the y's and do the arithmetic to make sure it's the correct number. Let me do all the arithmetic on the left side first. 9 times 5 is 45. 45 minus 30 is 15. On the right side, 2 times 5 is 10. 10 plus 5 is 15. So you can see I found the correct number that will make the left side equal to the right side. Remember I said that algebra is nothing more than arithmetic. Look at this original equation to see what it's made of. On the left side, it has a multiplication and subtraction. On the right side, it has another multiplication and an addition. It has 4 basic arithmetic operations in it: multiplication, subtraction, another multiplication, and an addition. Nothing mysterious, just a string of simple arithmetic operations. What you had to do to find the missing pieces was to first simplify terms, then reduce the equation to a letter on the left side and a number on the right side by following some simple arithmetic rules. Okay, let's look at one more equation like this. And as in the beginning, I'm going to use numbers that will keep the solution positive to make it easier to grasp the concept of algebra. I'm going to read this 2 different ways before I solve it. The first way is the way most people would read it. 16d plus 27 equals 10d plus 39. That doesn't really tell you what's going on here. But if I read it as, I want to find a number so that when I multiply it by 16, then add 27 to it, it will be equal to that same number times 10 plus 39. Now I want to solve it. I want to get all the d things on one side and all the numbers on the other side. I want to move the 10d to the left side, and you know it's a positive 10d. And when I move it across the equal sign, it becomes negative 10d. When I move the positive 27 across the equal sign, it becomes negative 27. Next, I can simplify the left side and the right side by combining like terms. 16d minus 10d's is 6d's. On the right side, 39 minus 27 is 12. I still haven't got the d by itself yet because it's still being multiplied by 6, so I have to divide both sides by 6 to get rid of it. On the left side, the 6's cancel out, leaving just d, and on the right side, 12 divided by 6 is 2. So the number I was looking for that would make the left side equal to the right side is 2. Now let's check it to make sure. Going back to the original equation, I'm going to plug in the 2 wherever I see the d, and then do the arithmetic to see if it makes the left side equal to the right side. Working on the left side first, 16 times 2 is 32. Next, 32 plus 27 is 59. Now on the right side, 10 times 2 is 20. Next, 20 plus 39 is 59. So the 2 will make both sides equal to each other. Now let's look at equations that have parentheses in them. First, we have to know how to simplify them and rewrite them before we can solve equations that contain them. Here's an expression that contains parentheses. First of all, let me read it. It's read as 2 times the quantity 6 plus 5. You can simplify this two different ways. Parentheses have priority in arithmetic operations, meaning that if you have a set of parentheses, you must do the arithmetic inside them first. So if I want to simplify this, I have to first add 6 plus 5 to get 11. Then I do the final operation, which is multiplication. 2 times 11 to get 22. So this expression is the same as 22. There's also another way you could handle this arithmetic. There will be times when you want to distribute the multiplier across the parentheses, then simplify. You could also interpret this as 2 is going to multiply everything inside of the parentheses. The 2 is multiplying the 6, and the 2 is also multiplying the 5. So I can distribute the 2 to those two numbers in order to get rid of the parentheses like this. 2 times 6 plus 2 times 5. I make sure I bring down the plus sign from here. Next I perform the multiplications. 2 times 6 is 12, and 2 times 5 is 10. The final step is to add those two numbers together. 12 plus 10, which is 22. The same answer I got doing it the previous way. Normally, you would simplify using the first method when you have all numbers and no missing parts. But if you happen to have a missing piece inside the parentheses, in an equation, you have to get rid of the parentheses first in order to solve the equation. Let's look at how to distribute across a set of parentheses before we solve equations with them. This expression is read as 2 times the quantity y plus 5. Now you can't simplify this using the first method because you can't combine or simplify the numbers inside the parentheses since you don't know how much y is. So you can't go any further with that method. The second method is what you use to get rid of the parentheses. What you want to do is to distribute the 2 to everything inside of the parentheses. The 2 is going to multiply the y, and the 2 is going to multiply the 5. And we bring down the plus sign between the y and the 5. Now this is just 2y, and 2 times 5 can be simplified to 10. So 2 times the quantity y plus 5 can be rewritten as 2y plus 10. Let's rewrite this expression by getting rid of the parentheses. It's read as 7 times the quantity a minus 3. To get rid of the parentheses, I have to distribute the 7 across to everything inside of the parentheses. I have to multiply the 7 times a and the 7 times 3 and carry the minus sign between them. 7 times a is just 7a, and 7 times 3 can be simplified to 21 and carry the minus sign down between them. How about this one? First read it to understand what it consists of, then distribute the multiplier across the parentheses to remove them. 5 times the quantity, 4 minus 6 times p. Now I want to distribute the 5 to everything inside the parentheses to remove them. The 4 gets multiplied by the 5, and the 6p gets multiplied by the 5 with the minus sign between them. Next I can simplify 5 times 4 to get 20, and I can also simplify the 5 times 6 to 30p. Okay, let's look at several equations that have parentheses in them. In the first example, the parentheses are on the left side. In the second example, the parentheses are on the right side. And in the third example, the parentheses are on both sides. First I'll read all three of these, then I'll show you how to solve each one. The first one reads 8 times the quantity m minus 3, which has to be equal to 4 times m plus 20. The second one reads 10x minus 15 is equal to 3 times the quantity 2x plus 3. The third one reads 2 times the quantity 2k minus 1 is equal to 3 times the quantity 6 minus 2 times k. If you look at these equations, it's not easy to try and guess by looking at them which number is going to work to make each side equal to the other side, like it was in the beginning examples I first showed in this video. This is why you have to learn the rules required to systematically take them apart to solve them. The more complicated they get, the more you have to rely on the rules or steps to take them apart in order to solve them. Let's solve the top one first. The first step is that I have to remove or get rid of the parentheses on the left side before I can move things around. The 8 is going to multiply everything inside the parentheses. 8 times m to get 8m, and 8 times 3 to get 24. And I carry down the minus sign. I bring down everything on the right side just as it is. Next I want to move all the letters to the left side and the numbers to the right side. The 4m on the right side is positive, so when I move it across the equal sign it becomes negative. The negative 24 on the left side becomes positive when I move it across the equal sign to the right side. Next, I combine the m terms. 8m minus 4m is 4m, and on the right side, 20 plus 24 is 44. The last step is to divide both sides by 4 to get rid of the 4 multiplying the m, so I get m by itself, and on the right side, 44 divided by 4 is 11. Now let's check it to make sure I found the correct number. I'm going to plug the 11 in wherever I see the m, then do the arithmetic on both sides. I'll do the arithmetic on the left side first. Inside the parentheses, 11 minus 3 is 8. Next I multiply that by 8 to get 64. On the right side, 4 times 11 is 44. 44 plus 20 is 64. So 11 is the correct answer. Now for the second one. You'll notice that the parentheses is on the right side here. I'm going to have to distribute the 3 across to everything inside the parentheses to get rid of them. First carry down everything on the left side, then distribute the 3 across the parentheses. 3 times 2x is 6x, and 3 times 3 is 9, and carry down a plus sign. Next I have to move things around and collect like terms. I want to move the positive 6x on the right side to the left side, and it becomes negative when I do that. The negative 15 on the left side becomes positive when I move it to the right side. Next I combine or simplify the terms. 10x's minus 6x's is 4x's. On the right side, 9 plus 15 is 24. I have to divide both sides by 4 to get rid of it on the left side, and on the right side, 24 divided by 4 is 6. Now I have to check it. Wherever I see an x, I replace it with the 6 and do the arithmetic on each side to make sure they are equal to each other. Let's do the arithmetic on the left side first. I have to multiply 10 times 6 to get 60, then 60 minus 15 to get 45. On the right side, I have to first multiply 2 times 6 to get 12, then add 12 plus 3 to get 15. Last, I have to multiply 3 times 15 to get 45. So 6 is the correct answer for this problem. Okay, now for the last one. I don't think there's many people who could guess the correct number that would make the left side equal to the right side by looking at it. But we can figure it out by taking it apart according to the rules of algebra. So let's get started. First I have to get rid of the parentheses on both sides. On the left side I have to distribute the 2 across to the 2k and the 1. 2 times 2k is 4k, 2 times 1 is 2, and carry down the minus sign. On the right side, 3 times 6 is 18, and 3 times 2k is 6k, and carry down the minus sign. I want to move the minus 2 over to the right side and it becomes positive. Moving the minus 6k over to the left side makes it positive. Adding 4k to 6k is 10k. On the right side, 18 plus 2 is 20. Dividing both sides by 10 leaves k on the left side, and 20 divided by 10 on the right side leaves 2. Now let's check to see if 2 will make each side equal to each other. Plugging in 2 wherever I see a k, then doing the arithmetic on each side. I'll do the arithmetic on the left side first. I first have to do the innermost parentheses arithmetic first, which is 2 times 2 equals 4. Then I have to finish the arithmetic inside the parentheses, which is 4 minus 1, which is 3. Next, I finish multiplying 2 times 3, which is 6. On the right side, I have to do the innermost arithmetic first, which is 2 times 2, which is 4. Then finish the arithmetic inside the parentheses, which is 6 minus 4 to get 2. And finally finish multiplying 3 times 2 to get 6. So k equal to 2 will make both sides of the equations equal. In this video, I made sure I chose all the examples so the answers would be positive. I did this in order to focus on the concept of algebra and the rules in order to make it easier to understand that algebra is just arithmetic. The arithmetic and the equations can and do get more complicated, but if you understand the arithmetic involved, you can always work backwards to solve the equation. It's a matter of learning the arithmetic rules, such as working with signed numbers, which is learning to add, subtract, multiply, and divide with positive and negative numbers, and will be the next step in learning to solve more complicated equations.